Hey y'all, we are gonna do one variation of parameters practice problem here. The question could be written in a couple different ways. You could see it like this: x prime equals this matrix times x plus 60, 90. That line or that equation there is equivalent to these two equations together. Because if you do some matrix multiplication and then write them as separate equations, then you're going to get this right here. I'm going to do this a little bit of board work style, where I give you this problem and I want you to try to do this. In a moment, I'm going to pop up the answer. Don't worry about it yet. It's not coming up yet. And you can try it if you want on your own and then check your answer with me. Or if you're just like, nah, I need another example. I need you to show me one more. Then you can just watch after I show the answer, and hopefully you'll get more comfortable with this variation of parameters. So at this point, if you would like to try this problem on your own using variation of parameters, which is this formula right here, go ahead and do that. Hit pause, do it. Okay, I'm going to put your answer up in a moment. Okay, remember, it's always xc plus xp. The xc is kind of a form of the fundamental matrix itself. And then the xp, which you should get from this, is this right here. So if you got that using variation parameters, awesome. And now if you want to just watch me go through it, or if you got it and you want to watch me go through it, then that's fine. All right, so the first thing that we need to do with this is calculate our xp, because that's part of our formula. So the xp we get from this right here, that is, I do my lambda squared, I do a negative trace, that gives me minus 4 lambda, and then I do my det, and that gives me minus 5 equals 0. Factors 2, lambda minus 5 and lambda plus 1 equals 0. So I get a lambda equals 5 and a lambda equals negative 1. With my 5, I will give myself a little bit more space, a little bit more. There we go. I'm going to do, all right, 6 minus 5 takes me to 1, negative 7. And then 1 and then negative 2 minus 5 takes me to negative 7. All right, they line up. That's good. So I take 7, 1. That winds up being this piece right here. Get out of here. That winds up being this piece right here. And then my lambda equal negative 1. I'll add 1 along the diagonal. That gives me a 7, a negative 7, and a 1 and a negative 1. Good, they line up, and I can take 1, 1. That's where this comes from. So my fundamental matrix is equal to, which way do I want to do this? I'm going to actually do this vector first, just because I like having the easier parts out front. So I'm going to go e to the negative t and e to the negative t. That is the 1, 1 with the e to this eigenvalue. That is the first column. The second column is going to be 7 e to the this t, which is 5t, and then 1 e to the 5t, which I'll just write as that. So remember, this is a square matrix. Now what I'm doing is taking this formula right here. So remember that formula has this f of t in it. In this case, the f of t is the input for this equation right here, which is the 60, 90. So I'll write that down here, comma f of t equals 60, 90. All right, so what I'm going to do is build everything off of this line that I have right here. So what I mean by that is I am going to write x integral, and then for the first step, I'm going to write x inverse. Well, actually, so I need to calculate x inverse. So let's come over here, and x inverse is equal to, all right, 1 over, all right, the det. Notice when I do this multiplication and that multiplication, they both give me a e to the 4t. So it's e to the 4t, and that's because of an e to the negative t times an e to the 5t. And then what we're going to get is this, the product coefficient pieces of this, which is 1, minus this, which is 7. And that'll work every time because the columns are always going to have the same exponential pieces, times Remember that A, B, C, D inverse is 1 over the DEET, which is AD minus BC. You should be familiar with that. Times, all right, I switch the D and the A, and then I negate the B and the C. So that works with this equation here too. So I switch the D and the A. That gives me a e to the 5t here, and an e to the negative t here. And then when I negate the other two, I get a negative 7 e to the 5t and a negative e to the negative t. From there, I need to simplify this a little bit. So we are going to get, all right, this, I'm going to leave the negative 1/6 out front, 1 over 6. And actually what I'm going to do is I'm going to apply that negative into these terms right here. So this one's going to be negative, and this one's going to be negative, and the other two are going to be positive. From there, I need to divide by e to the 4t, or you can think about it as multiplying by e to the 4t. So when I multiply by e to the negative 4t, when I do that for this term, it turns to e to the positive t. I just subtract the 4 from the 5. Same thing with this. Remember, I'm going to have a positive 7 because I'm applying this negative in there because it's easier that way. And then this one's also going to be a e to the positive t. And then when I do this one, I get negative t minus 4t. That takes me a e to the negative 5t. Double check my signs. This was negative. Now it's positive because I moved that in. And then this guy is negative, and we get the same thing, e to the negative 5t right here. All right, so now I've got x inverse. So I can write that right here. That was my spot right here. I got to here, I was like, oh no, I don't have x inverse. So this is equal to, and I'm actually going to pull that 1/6 all the way out front because I don't want to have to deal with it anymore. So, or I don't have to deal with it if it's unnecessary. So now I got to write my x inverse, which is this right here. So open parentheses, negative e to the t, 7e to the t, e to the negative 5t, and negative e to the negative 5t. All right, now I got to multiply it by f of t. Well, that's this right here, this 60, 90. And this is a case where actually, I moved this 1/6 out front, but now I look at it and I'm like, oh, I'm going to move it back in to make it so that this stuff here is easier. So let's do that. I get x integral. I'm going to just, when I divide 60 by 6, we get 10. And when we divide the 90 by 6, we get 15. So that's going to be nice to have. All right, from there, this is equal to x times the integral. Order operations, I got to multiply first before I go and integrate. So that gives me, notice I've got square matrix by column vector. So I'm going to go across and down. This one is going to get a 10, and this one's going to get multiplied by 15. That's going to give me negative 10 e to the t, and then plus, all right, 15 times 7 is 105 e to the t. And then the bottom row is going to give me this times this, which gives me a 10 e to the negative 5t, and all right, a minus 15 e to the negative 5t. And this is convenient here because look, e to the t, e to the t, e to the negative 5t, e to the negative 5t, I can combine like terms. So I'll just do minus 10 in the 105 and 10 minus 15. So we get these right here. Now we need to integrate that. So I'm going to get x, and then, all right, the integral of 95 e to the 5t is just 95, e to the, just t, not a 5, e to the t. And then this thing integrates really nicely. It just gives me a e to the negative 5t because of some chain rule. Now I got to multiply by the x, so I'll write that out. Remember, x was all the way up here. It was this thing right here. So I will write that down here. I get, open parentheses, e to the negative t, 7e to the 5t, and then e to the negative t, and e to the 5t, that's x, and then I'm multiplying it by this right here, which gives me 95 e to the t and e to the negative 5t. All right, and look, this is super, super, super convenient to multiply, because when we go across and down, notice I get an e to the t times a, sorry, e to the negative t times a e to the positive t. So when I do that multiplication, they turn into a 1. They cancel each other out. So the first term, when I do this boom, boom, just gives me my 95. And then here I've got a 7 e to the 5t times a 1 e to the negative 5t. Again, the exponentials cancel and just give me a plus 7. Same thing's going to happen down here. We're going to get this times that. The exponentials cancel, and I get my, whoops, come on, get out of here. I get my 95, and then my next product gives me a plus 1. And that gives me 102 and 96. This kind of thing should happen frequently depending on the input that you have, the cancellation. Say I had t's up here, then I would get stuff with t's out, hopefully. Say I had a e to the 22t, I should get e to the 22t's here when these things multiply. It should always, always work out if you've done your work correctly. So remember, this is xp, and remember, x of t is xc plus my xp. Now remember, xc is just the solution to this thing equal to 0, which is what we would have gotten. It is, you know, the fundamental matrix here is another way of writing all those solutions together. So it would be c1 times this vector plus c2 times that vector. So my x of t is c1 times, get out of here, what do I get? 1 e to the negative t plus c2 times 7 e to the 5t plus my xp, which is 102, 96. So that's it. Hopefully you see that. You're getting the hang of this, and you're ready to try some more. And here is a big picture view of everything that happened, and I'll just kind of quickly review it. All right, here we go. This is our f of t. I calculate my eigenvalues and eigenvectors the same way I would for it without this 6090, and then I smash that into a fundamental matrix. From there, I use the formula for variation of parameters, x times the integral of x inverse f of t. And I need to find the inverse. So that's what this work is here. And remember, we can use this inverse formula for it. And then I start my multiplication. Do my multiplication, deal with the 1/6 if that kind of thing is possible. Do some multiplication, get to this, integrate everything. Sometimes the integral step is the biggest piece to work through. Sometimes you get some integration by parts in there. So just be ready for that. Then once we, I guess this is the integral step right here, right? But sometimes in order to get from this line to the next line, we have to do integration by parts. And then you just have to multiply your square matrices. And we come out and we get this. And my solution is the C stuff plus the XP. Peace, y'all. Thank you.